Welcome to today's webinar, AWS Lambda, Event-Driven Code for Devices in the Cloud. Our presenter today is Olivier Klein. Olivier has been working for Amazon Web Services across Asia Pacific and Europe to help customers build resilient, scalable, secure, and cost-effective application architectures. He advises on how to build platforms that align IT infrastructures, spending with revenue models, effectively reducing waste and disrupting how product development has been executed over the past decades. Today with us, we also have Aishwara, Audrey, Anghwa, TC, and Kenda. They will serve as our webinar moderators and will answer your questions throughout the presentation while Olivier presents. Olivier, welcome. The floor is now yours.
Hey, good morning or good afternoon, everyone, depending on where you dial in today into this today's webinar. So I see that based on some of the polls, some of you are fairly new to AWS, fairly new to AWS Lambda, and some of you might have had some experience. So in today's webinar, we want to run through some of the use cases of AWS Lambda, a little bit of background, how it works, and some of the sources that we can use it for. So first things first, AWS, Amazon Web Services, deploys a global infrastructure all across the globe with currently 13 regions, including 5 or 6 in the Asia-Pacific region. Within those regions, we have so-called availability zones, which are clusters of data centers, which allow your application to run in one single region and yet be available in multiple of those data center clusters, allowing your application to be highly available. In addition to that, we also have 59 edge locations all across the world that help to accelerate the network connectivity to your end user. Now today's talk is about AWS Lambda. And AWS Lambda is currently available in the regions that you see now with the Lambda icon highlighted on this map. And we recently also launched AWS Lambda in our Singapore, in our Sydney region. Now important to know, AWS Lambda is a service that inherently uses multiple availability zones within the region of your choice, allowing you to run your code within AWS Lambda always highly available. Now what is AWS Lambda? AWS Lambda allows you to run your code highly available in the cloud in response to events, and it will scale without any servers to manage, which allows you to focus on your business logic and not on infrastructure. No more servers. You just put in your code and we do the rest for you. It also automatically scales to any incoming event throughput. Any amount of function calls that you have against AWS Lambda, we will automatically scale the underlying infrastructure and match that event rate. And we allow you to bring your own code, and we currently support JavaScript, Java, and Python, and more programming languages coming up soon. Now, let's dive a little bit further in. What does that mean if we don't need to manage infrastructure anymore? It allows us to run completely serverless. We upload our code into an AWS Lambda function, and AWS will then handle all the capacity planning for you, all the scaling. We will make sure that we deploy it accordingly, across multiple availability zones. We allow you to monitor the function through our monitoring tools, log everything and what's going on, even allow you to do all that through our console and our web service front end. And we also take care of the security and patching of the underlying infrastructure that runs your code. When I say automatic scaling, what does that mean? Lambda will automatically scale to any amount of incoming event rate or throughput that you have against the AWS Lambda function, which means you don't need to worry anymore about over or under provisioning. You don't need to worry anymore about how much is my utilization of a certain server, how much percentage of my CPU or memory am I using. All of this fades away. And the best part is you pay only for what you use when you use it, which also allows you to create new applications, and even if those applications are successful and go highly viral, you wouldn't have any issues around needing to make sure to scale up or scale down whenever you need to. Talking about pricing, Lambda is designed to have a very fine-grained pricing model. We actually only charge you for the execution time of your code in 100 millisecond increments. There's a very low request charge, and there's no hourly, daily, or any monthly commitment or minimum that you have. No charge on a per device fee, which means that you never pay for any idle compute power. You never pay for any underutilized resource. Only when you use the computational time, only when your code runs, that very moment, you get charged on a 100 millisecond increment basis. We also provide a free tier every month for every customer where you can have a million requests and over 400,000 gigabyte seconds of compute time for free every month. Now, let's dive in a little bit further. When we talk about AWS Lambda, we talk about Lambda functions. Now, those Lambda functions are stateless, meaning that you create the function, you upload your code, and this code is executed whenever there's an incoming event or whenever you invoke it via an API call. Why is it stateless? Well, if the function runs after it terminates, it loses all the state that has been stored within that function. So if you create an application on top of AWS Lambda, you got to be aware of the fact that the code needs to be stateless. Now this function can then be invoked straight from your browser, for example via an API call, or even straight from your mobile application via the help of our mobile SDKs, which are available for iOS and Android. In addition to that, the stateless Lambda function can also be triggered by events from other services, so-called state transitions. Things like if you have a new file, a new log file, for example, that lands in your S3 bucket, execute the Lambda function. If you have a new item or a new row written into your database table, execute the Lambda function. If you have a new message that comes through your real-time processing Kinesis stream, execute a Lambda function and process that message on the real-time processing stream. And those event sources span across multiple services of AWS. So we talk about data stores, we talked about S3, DynamoDB, and Kinesis, but it also works with Amazon Cognito. We also offer integration into other endpoints, such as our Amazon Echo device and the Alexa voice services, which allows you to build your own Alexa skill with your own Lambda function. Things like Amazon API Gateway, in which we dive into more detail in just a bit. AWS IoT, which allows you to connect potentially billions of things and devices to the AWS cloud and then have an AWS Lambda function in the backend to trigger your logic. Repositories like our AWS CloudFormation templates, AWS CloudTrail, which creates audit files about all the activities in your accounts, Amazon CloudWatch, or even Amazon Config, which allows you to create inventories of your entire AWS setup and have a Lambda function execute based upon changes to control, for example, if your environment is still compliant. Other event sources would be Amazon SCS, our simple emailing service, which would allow you to react upon incoming emails with an AWS Lambda function. Amazon SNS, our simple notification service, and even scheduled events, which you could, for example, use Lambda in a form that it becomes something like a cron job. Execute that Lambda function every minute, every 5 minutes, or every hour, or a certain day in the week. And the fact that AWS Lambda can be used in such an interesting way, being connected to API gateways and different event sources, allow our customers to create multiple application types on top of AWS Lambda. So for example, some of our customers like Zillow or the Major Baseball League use it for analytics, operational management, or live dashboards of incoming events. Other companies like Twilio, Zapier, Slack use it for interactive backends to create bots or webhooks via AWS Lambda functions. Other companies like Thomson Reuters or FireEye use it to create data workflows, to do content management or ETL workflows for their big data applications. Other companies like Netflix use it to actually create policy engines to make sure that the IT environment is always compliant with the security requirements that they need and have. And they also use it to actually manage the infrastructure, to manage their virtual servers, their EC2 instances in AWS in an automatic and scalable and programmable fashion. Now, let's get started and try this out in a live demo. So I'm going to switch now to my AWS console and show you how we're going to create our first Hello World Lambda function. You should now be able to see my screen. Here I'm in my browser and you see the AWS Management Console. Here we have an overview of the variety of services that we offer, and today we're going to focus on the service right here, AWS Lambda. Let's click on it. By the way, currently I will execute or I will try this demo in our Singapore region. If you ever want to change this region, you just click up here on the upper right hand corner and you can see the different regions on where AWS Lambda is available. If I want to create an AWS Lambda function, I will click on this Create a Lambda Function button. The next thing that happens is that with AWS Lambda, we have so-called blueprints. Blueprints are sample configurations with event sources and Lambda functions that gets you started quickly if you want to build a certain thing on top of AWS Lambda, such as, for example, react upon a new S3 object or, integrate with our API gateway. Today, we're going to use a blueprint for a hello world. So I'm going to filter this, and then we can look at which runtime do we want to use? Do we want to use Node.js or Python? By the way, we can filter through the blueprints, also the runtimes for the blueprints up here. Currently, we have blueprints available for Node.js and Python, with more blueprints being added all the time. I'm going to select Hello World function within Node.js here. After doing so, I can configure the trigger for this AWS Lambda function. The trigger means how do we actually execute this AWS Lambda function, which could be by integrating it into event sources like DynamoDB, S3, Kinesis, or API gateway, for example. For this simple Hello World demo, I'm not going to integrate it with any other service, so I'm going to leave this empty and just say, just create the Lambda function for me without having an event source trigger. In the next dialog, I will actually need to give this function a name. So I will call this my Hello World function. I can also give a certain description here. So I say, this is my first Hello World function. Next, I can choose the different runtimes that I want my code to run in. Here I'm going to leave it at Node.js, but I could also choose Java, Python, or a different version of Node.js. Now we can actually enter the function code, the code that our Lambda function should actually execute. Here we can use the inline editor, which you see right here, or we can also package our code, put it in a zip file and upload it, or if we already have a zipped piece of code in our Amazon S3 bucket, we can also choose this. For this demo, I'm going to edit the code inline. Now what you see here is a sample code that basically will just do a little output on the console and then set, basically do a callback action that will return the value that we pushed into this Lambda function. So a Lambda function generally always has a handler which will be called upon execution of the function. Here it will be the exports handler for Node.js. If you wonder why is it called handler or what function will be executed first, if you were to add other functions down here, if we scroll a little bit down, you will actually see that down here we can indicate what handler should be executed first upon the call on this Lambda function. So since we have handler here, we will execute this function right here. If we execute a Lambda function, we can always send certain information back into that Lambda function. They will be made available in the event object here. So by the piece of code that we're doing here, we will actually look at the incoming JSON object and extract key 1, 2, and 3, log it out into the console, and then send back key 1 from the incoming JSON object. Going down further here, Lambda also executes within a certain IAM role, an identity and access management role, which is the service of AWS to control and secure your environment and define exactly what kind of access you want to give to the different AWS services. Similarly, as you need to log in, for example, into the management console, and if you were to create users for your developers, you can use IAM groups, users, and roles. A Lambda function also needs to be assigned the kind of permissions that it has to access your AWS environment. And this is what this role is about. We can create a new role or create a custom role, or in this demo, I actually pre-created an IAM role. So I'm just going to choose from an existing IAM role, which will define what kind of access functions this Lambda function will have onto my other AWS services. Next, we're going to configure how much memory we want to allocate to this Lambda function. Now, important to note, this memory that is allocated is for one function call. So if you actually have multiple functions being executed at the same time, such as, for example, if you use Lambda to create your own APIs through our API gateway, these 128 or 192 megabyte of memory will be available for every individual of that function calls. So if you think about choosing the amount of memory that they require, think about how much this piece of code will require for a single execution. In this scenario, since we only do some basic output, I'm happy with this initial 128 megabyte of memory because we don't really need much memory to actually just do a hello world program. If your function becomes a little bit more complex, you can go all the way up to 1,536 megabyte of memory for that individual function execution. Lambda functions also have a timeout. A timeout means that if your code doesn't successfully execute until the timeout threshold has been reached, the Lambda function will be cut off. This is made in a manner that you don't have a Lambda function that might get stuck in some form of infinite loop and basically waste compute cycles without actually creating value for your business. However, be aware of this timeout so that you create it in a manner that it should execute, the piece of code should execute within the threshold of the timeout function. If you set it too low, your function might not be fully executed and actually will be removed. Now, if you wonder, will this timeout function mean if I put it on 10 seconds that this function will always run 10 seconds? No, your function will actually stop whenever you call the callback function. And we will only charge you for the millisecond that have been executed until the callback function has been executed. However, if your callback function for whatever reason is not called, which sometimes can happen, you might have a piece of code where you accidentally forget to put in that callback function, the timeout will then kick in and push this function down or finish this function, terminate it after, in this scenario, 10 seconds. For this Hello World demo, I want to have this call back, so I'm going to put this back in here. Lastly, Lambda functions can also allow you to run or actually connect those Lambda functions into your virtual private cloud, VPC. This is interesting if you want to run Lambda function in a complete private subnet, for example, of yours to control, for example, some of your virtual server infrastructure. In this scenario, we want to create a Hello World program that is potentially publicly available, so I'm not going to connect it to any of my VPCs. If I'm all done with this, I'm going to click the next button here. Now I will review what I have done. So I created a Hello World function with a certain execution roles, 128 megabyte of memory, timeout seconds of 10 seconds, and not attached to a VPC. So I'm going to go ahead and create this function. There we go. We now have created our first Hello World function. And we see now here we still have our inline code editor. We also have a configuration tab where I can change at any point in time some of the settings I just made. I can also add new triggers to this Lambda function. Earlier I chose not to add a trigger. If I ever want to add another trigger to this Lambda function, I can do so via this dialog. Lastly, we also have a monitoring tab, which allows us to have a look at how often this function has been executed, if we had some errors, if something has been throttled, and it also allows us to look at the output of the console in the CloudWatch logs via this link. If I click it, it automatically brings me to the CloudWatch log files of this specific Lambda function. Now, if I want to go ahead and test this function, I can actually go up here and click on Actions and say I want to configure a test event. If I configure a test event, we provide you with a few sample event templates. In this scenario, I'm going to use the Hello World template. You see that it has been pre-populated with some JSON string that we want to send to this Lambda function to test it. So here, I'm going to say this is a test. And let's have a look at what this function will do. If we execute it, we should see in the output this is a test because we wrote that to the console, and the return value should be test because we return key 1. So let's save this and test the function. Now you'll see if we scroll down, the function has actually executed, and down here we see the exact log output of what has been happening. And here we see value 1, 2, and 3 as per the piece of code above has been executed, and we see this is a test. Our callback up here also returned the event key 1, and that is what we see as execution results here, where test came back. Lastly, the log output also shows us exactly the amount of time that this function has been running. Here it was a simple output, so it only took a little bit less than 3 milliseconds. And we also see the amount of duration that we have been charged against the execution time of this specific Lambda function. Great. Now we have created our first AWS Lambda function. Now let's go back to our PowerPoint slides and have a look at what else we can do with AWS Lambda. If we think about how we build application backends for web applications or mobile applications, we generally have the scenario where an end user is using his device, his laptop, maybe his mobile phone, talks to a certain backend logic, and based on whatever the backend logic is doing, might read or write to a certain database. Now, if you were to build this in the past, you probably ended up creating a 2 or 3 tier web architecture where you have web servers and maybe application servers and a database backend. With AWS Lambda, we actually can create serverless web and mobile applications, meaning that we don't require any servers anymore by the help of AWS Lambda. How does that look like? Well, basically we replace the 3-tier web architecture with microservices that are powered through AWS Lambda and Amazon API Gateway. And if we ever need to use a database, we can use fully managed databases such as Amazon DynamoDB. Now, if you wonder, what is Amazon API Gateway? Amazon API Gateway is a fully managed and scalable RESTful API Gateway service. So it allows you to create APIs for your end users. And those are powered through our content delivery network, with its 59 global edge locations all across the world. This allows you to create APIs that are not only highly available, but also highly scalable and really easy and fast to use for your end users because they will be channeled to the global edge locations all across the world. They will be directed to the edge location with the lowest latency to their current position. In addition to that, Amazon API Gateway also provides you with distributed denial of service attack protection and also throttling capabilities for your users. So if you ever have a certain user, an abusive user, you can start throttle him. Or if you have certain models for your users, you want to create APIs and you might have a basic model and some premium models for paying users, you can set different throttling values for different kind of users here. In addition to that, Amazon API Gateway also allows you to version and stage your different API API setups. So for example, you can create certain development and test environments or production environments and create different versions of your API and redirect it back to your piece of code. Now, where does your code sit? Well, this could still be in virtual servers such as EC2 or even your on-premise servers. But what we're trying to achieve here is to use AWS Lambda to execute our piece of code so that we have a serverless, highly scalable, and highly available API function. Now, earlier I mentioned that an AWS Lambda function can be called directly via certain event triggers and also directly via the SDK, such as, for example, the JavaScript SDK directly from the browser or some of the mobile SDKs directly from your iOS or Android application. Now, you might wonder, why would I choose to actually plug in API Gateway in front of the AWS Lambda function instead of just calling it directly? Well, you can do both, but if you use the API Gateway in front of it, you have a variety of benefits. First of all, it is easy for you to interchange the backend logic of the Lambda function at any point in time without actually doing any modifications on the client logic. This is especially important for native mobile apps, where often a change of code will actually trigger a new release into the App Store or the Google Play Store, which again comes with a certain review. So there's lead time towards changing functionality. With the API gateway, we have a front door, which we can always keep the same and version in a certain manner, and we can easily interchange the code behind, change it to other Lambda functions without actually changing our front end. As mentioned earlier, API Gateway also protects you against DDoS attacks, and those from network layer attacks, layer 3, such as synflots, all the way up to counterfeit HTTP requests, for example, which would be layer 7. It also gives you the ability to easily throttle individual users or individual requests. And more importantly, it also adds a caching layer for your calls. So if you have certain API calls, it allows you to actually cache some of those calls back to avoid continuous execution of your Lambda function or requests against your database table if it hasn't changed. Lastly, it also allows you to enable coarse cross-origin resource sharing for all other AWS services for your web application so that you don't have any issues if you have different domain names. Now, we also recently launched a certain micro framework called Chalice. Chalice is a serverless micro framework for AWS, which allows you to use this combination that I just showed, a microservice with the help of an API gateway and an AWS Lambda function fairly quickly via a few lines of code. It will automatically create a sample code for you, which allows you, and you see that here on the right side, to define certain routes for your API and then define a piece of code that will then be executed in your AWS Lambda function. It also allows you to quickly deploy this piece of code out into a Lambda function and set up your API gateway with the respective resources and methods with a single command line execution, which would be Chalice deploy. And it will automatically deploy it out to our Amazon API gateway, create the Lambda function, hook everything up, set the right configurations about IAM roles and permissions and security settings, and creates the resources with an API gateway to create the endpoint that you want to have. By the way, Chalice is open source, so if you find it on GitHub under github.com/AWSLabs/Chalice. And if you haven't checked out our GitHub page, I encourage you to also go to github.com/AWSLabs, where we always share interesting pieces of code for a variety of our services, all open source for you to use and modify as you wish. Now, let's go ahead and try this out in a live demo. I'm going to try to use Chalice to create my first serverless API backend. I'm going to create 3 different function calls, and I will use Chalice to automatically build and deploy this out to Amazon API Gateway and AWS Lambda. I will then go into my Amazon API Gateway console and actually download the different endpoints definition file and then load it up into Postman to then test these APIs that we just created. All right, let me switch over now to my console to actually do this live demo. And here again, we see our AWS console. I'm going to go back and we're going to look here at the different services that we're going to use. So we're going to use API Gateway here, and we're going to use again AWS Lambda up here. Now, as seen earlier, I could easily create a Lambda function, write my piece of code, and then hook it up with an event trigger to API Gateway. This works well for single functions, but generally if we have more complex setups, we definitely want to have some form of framework to handle this for us. So for this, I'm going to use Chalice. I'm going to switch to my console down here, and I'm going to make this a little bit bigger so everybody can easily follow this. And you'll find that earlier I executed Chalice, and I said, Chalice, create a new project for me and call it Hello World. Chalice that very moment created some application code for me and a requirements.txt file. It also created, if we do a listing of my entire folder, a certain hidden folder called .chalice. If we go into that folder, you will find that it created a certain configuration file which will tell us the app name and the stage in Amazon API Gateway that we're going to use. In this scenario, we're going to do a hello world function in a development stage. Now let's have a look at the piece of code that has been created. Chalice basically is a Python microless serverless framework, so we're going to import it here at the top via Chalice, and then I'm going to call my application here hello world. I already changed the code and defined a few routes down here. These routes will be my API endpoints later that I can call. If I call the root route here, I will actually return hello world as a JSON object back to the caller. I created another application route here where I say /city/ and then I put in a variable because API Gateway also supports variables and Lambda also supports variables of the user input. So here we're going to say if I enter a certain city, if it would be Seattle or Portland, it would return to me the state of Washington or Oregon for Portland back to the caller of that function. Lastly, I also created an /introspect route or resource here. The introspect function here will do nothing else but to just return exactly the incoming request that I sent to the API and put it back into a JSON string and return it to me. Now, I'm also going to go ahead and add something in addition to it, and we're going to use our copy-paste method here of actually creating a new function. I'm going to say this is the webinar. I'm going to say hello webinar attendees. I'm going to write this out into my Python code and exit it. Now, if I want to deploy this new function out, all that I need to do is to say Chalice deploy. And what Chalice will now do is it will talk to the AWS API, it will create the necessary IAM policies, it will create the Lambda function, package the piece of code I just created, send it to the AWS Lambda function, deploy it out, create the API gateway resources, add the new resources that I just added, deploy it to the stage of that Amazon API gateway, and it will return me with the new endpoint on which this API has been deployed. So if I copy this and I put it back into my browser, remember this is the root down here, so we should see a hello world coming up. Let's try this out. I execute the function, and there we go. We now see the JSON string hello world. Now let's go back into our console and have a look at what actually happened here. If I click onto Lambda, and by the way, I deployed this into our Tokyo region because my current command line is set up as a default to the Tokyo region, we will find that a certain Lambda function has been created here, which is called hello world. Just adjust this right here. You see hello world has been created 1 minute ago, automatically deployed by Chalice. Let's go back to the main interface and have a look at API Gateway. See what has been deployed by Chalice in my API Gateway. Chalice has automatically created the API down here, hello world. It also created the different resources here, the /cities, /webinar, /introspect, and created the different methods on top of it. So for example, the webinar function that I just created, it created a get function here. By the way, Chalice also supports other HTTP methods, so it could also work with put posts or option calls in your HTTP or delete calls. If I click on this, I'll see that actually it created this /webinar method, and it attached it to my Lambda hello world function. It also made this public by not requiring an authentication in my Amazon API gateway, but I could change it at any point in time. It also allows me to actually test this function. So let's see if that actually works. Remember what we did when we wrote the code? We said on /webinar, we actually return hello webinar attendees. So if we test this function, let's see what happens. And our response body would be hello webinar attendees. So our Lambda function executed successfully through our API gateway. It also created a stage, and remember that stage was called development. So if we click on stage here on the left-hand side, you see it created a dev stage here, and it deployed all these functions out into this stage. It also gave me then a URL, which you see up here, which allows me to execute this in my browser. Let's try this again in my browser. If I click on this and I would change it to a /webinar, we would see hello webinar attendees. We also created another function which was cities. So let's try this out. If I try cities and Seattle behind it as a parameter, I should now get a return, and the return should say Washington State, which happens now here. Now, if we look at testing this, the more complex this piece of code might become, I certainly don't want to use my browser and manually test all these functions, so API functions true. So one other element of how you effectively can create microservices with API Gateway and Lambda and then test it is to use some other third-party tools. And notably, there's a third-party tool called Postman, which allows me to load in API definitions and then test them with certain parameters and continuously do regression testing through Postman. Now, API Gateway also allows me to take this current definition and then export it easily into these third-party tools such as Swagger or in this scenario, Postman. So if I want to do that, I can say download this current file as a JSON file. This is the definition of my API with all the respective Lambda functions behind it, and I can now load it up into my Postman application. By the way, Postman is also available as a Google Chrome app, so I can easily install it into any Google Chrome and then launch Postman right from there. Next thing that I can do is to say I actually want to import this API definition file that Amazon API Gateway has created for me. So I'm going to go to my downloads folder, and down here we have our Hello World definition file, which I'm now going to import as a copy here because I already previously loaded that in. Now what you'll see here is Postman now loaded up all these definition files with the different function calls, and it allows me to now easily go ahead and test this function in Postman. I can also create certain scripts or specific test variables to say I want to check, for example, if the response body actually has webinar in his word, and then send this again and test it out and see down here if my test has been executed successfully. Yes, it has. If we change this out to would it actually have AWS in its response body, we would get a fail on this specific test. It also allows us now in the future to change our API code and at any point in time go back to our Postman here and say I want to run through all my API tests and see if they have been executing successfully or not. So a great way to actually go ahead, monitor your APIs at any point in time, having them completely serverless run through AWS Lambda and API Gateway, easily deployed out via the help of frameworks such as, for example, Chalice. Now let's go back to our slides and see what else we can do with AWS Lambda. Earlier I mentioned that we can use AWS Lambda for web or mobile applications. If we think about a web application, generally it always translates back into certain HTML files and JavaScript files and CSS files and images and videos that are being sent to your browser. And then your browser allows you to then call back a certain backend, which now we know we can use Amazon API Gateway and Lambda to do it serverless. However, how do we actually get files like my JavaScript and HTML to the browser without running a single server? For this, we're going to leverage two more Amazon services. First of all, we're going to leverage Amazon S3, our simple storage service, which is a highly available and highly resilient object storage. Highly resilient in the sense that it's designed for 11 nines of data durability. So it's great, for example, for backups of your files because it's highly durable. By default, objects or files that you put in Amazon S3 are private. However, you can also define your S3 buckets to be public or make certain objects within that bucket public. Amazon S3 will then provide an HTTP or HTTPS endpoint to that public object in the Amazon S3 bucket. Now this makes it an ideal place to store HTML, JavaScript or CSS file and actually renders Amazon S3 something like a static web server. The benefit, although, from using Amazon S3 is that we don't need to actually run any single server to deliver those files out. Amazon S3 is also designed to be highly available and highly scalable. You don't need to tell us how much storage you require. You don't need to tell us how many requests you have against the S3 bucket. You just put in your files, as many as you wish, and Amazon S3 will automatically scale for throughput or more storage if you require so in the future. In addition to that, if we deliver a web application out to our end users, we generally want this to happen with very low latency. We want our end users to be able to see our website fast and efficiently. For this, we're going to use one more AWS service called Amazon CloudFront. Amazon CloudFront is our content delivery network service, CDN service, which again is channeled through our 59 edge locations all across the world. CloudFront can then be attached to a certain origin, such as, for example, your Amazon S3 bucket. If an end user is now accessing your CloudFront distribution, which would be through your domain name, the end user will be redirected to the edge location which has the lowest latency to its current position. The edge location itself also has the ability to cache some of the content from the origin. In this scenario, we're going to use an Amazon S3 bucket for our HTML and JavaScript files. So if a user accesses this through CloudFront, the edge location also has the ability to cache these content files, these HTML and JavaScript files, on the edge location, which is great if you think about a global application where you might choose to store your files in an S3 bucket in Singapore, but yet have users, for example, in the US to access your application. CloudFront can now cache these files on the edge locations in the US for fast access of your end user. Now this is great because now we have achieved to actually build our first serverless web application because we load our HTML files and all the necessary stuff into Amazon S3, channel it through CloudFront and send it then out to the end browser efficiently, highly available and highly scalable. Now there's one more thing. If we build a web application, we generally want to have the ability to actually interact with the end user and store some of the information that he sends back to us. Think about, for example, a comment functionality in a website where you want to store an end user's comments. Lambda is stateless, so where do we actually store the data? Well, for this, we're going to leverage another AWS service, specifically Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database service. NoSQL in the sense that you can store any kind of data in a schemaless data model. You just indicate a certain hash key and add any kind of attributes to the items that you store within the table. It's fully managed in the sense that it is highly scalable. It's seamless in terms of the way that it scales. You can have, for example, just 1 write per second against the DynamoDB table, but can also scale it up to hundreds or thousands of writes and reads against this database table at any point in time, turn that dial up or turn that dial down easily, seamlessly. There's also no limitation around the amount of storage that that database table has and the throughput that you hit against it. It is designed for consistent, low latency, single-digit millisecond latency performance. It's also designed for high durability and high availability by replicating your data across at least 3 facilities within the region of your choice. Now, if we now want to build a complete serverless web application, the architecture would look like this. We store all our files in Amazon S3 from our website, deliver it out via Amazon CloudFront to the end browser, then have JavaScript in our JavaScript SDK to actually call the Amazon API gateway for any kind of backend functionality, which in effect calls an Amazon Lambda function. And if we need to store state, we can do so in DynamoDB. If you want to use any other AWS service in your Lambda function, you're free to do so because AWS Lambda allows you to call any other service like SNS, SES, or Elasticache. Now, let's try this out in an actual demo. So we're going to try to build a small little website which allows us to create new comments on a website and post them out and load comments that previous users have been posting. They are stored in DynamoDB, and the function that loads or reads or writes to the database table, the DynamoDB table, is stored in Amazon Lambda. Now let me switch over to my console to show you how this works. And I will go back to my main console. Let's just close this tab down here. And first we're going to use Amazon S3 to actually upload certain files. If we go to the S3 dialog, the first thing that we would need to do is to actually create a bucket. Now, in the sake of time, I actually pre-created this bucket already, which I called API Gateway Demo. I also already uploaded the files into this bucket. So for example, the index.html file, some images, some fonts, CSS to make it look nice, and obviously also the JavaScript to be able to interact with my backend. If I click on properties on the right side here, you can see that I now have a public endpoint because this has been made public to actually access this API Gateway Demo. Now, I mentioned that we want to use CloudFront in front of it, so let's have a quick look on how that works. If we click on CloudFront down here, you will see that we can create a distribution. I pre-created this distribution, and you find down here that there's a distribution that is now connected to my API Gateway Demo S3 bucket. It will then give me an endpoint to actually access my S3 bucket through these edge locations all across the world. Now this URL can also be a custom domain name, so don't worry if this URL might not look very nice. You can use your own domain name on top of it. Now let's try this out and see how it works. If I hit this, we'll see we have a certain website down here. Now next is our Lambda function. Let's have a look at how our Lambda function looks like. I actually pre-created this demo in our US West Oregon region. And the reason I did this is to show you how important those edge locations are to actually accelerate connectivity, even if this is in other geolocations. Here I created two Lambda functions, one create new post and one get all posts. Let's have a look at get all posts first. In this Lambda function, I basically just call the AWS SDK, create a DynamoDB object, load up posts that are in lambda-demo-posts table, query this, and send this back in a comments object, which will then be sent back to my browser. So let's try this out. If I now use my Google Chrome Inspect console here and click the network, I will see what happens if I hit this load comments button. And you see down here, it actually makes a request against get all post against my API gateway, which in effect will then load the Lambda function, which will load up comments that have been stored in my DynamoDB table. Let's try this out and see if this also works by posting a new comment. Hello, webinar attendees. This is my first serverless web application. And I hit the post button, and we'll see that the create new post has been executed. Lambda function in the backend has written this to our DynamoDB table, and we then reload these new posts and see that hello webinar attendees has actually been written into our DynamoDB table, has been reloaded via the API call in the Lambda function. And I'm always glad to see that my webinar attendees are actually paying attention to what I'm saying here, and we just had a live comment coming through from one of the attendees who was writing a yo comment right here. So thank you for that. All right, let's go back to our slides to see what some of the best practices are to now use this for your applications. Now, if you've seen what I've done here, building some first hello world Lambda functions, building some APIs, building some serverless web applications with Lambda, you might say that's great. It allows me to be really agile and have all these highly available, highly scalable abilities now. But if I want to move this into my production, I don't really want to hit that save button and have that Lambda function go live straight away. Also, sometimes I have APIs that I want to version, and I want to say I keep a 1.0 version or 1.2 version. So can we actually keep different versions within my Lambda functions? And the answer to that is yes. AWS Lambda allows you to also version all the code that you load up into your AWS Lambda functions. Those are completely immutable versions of functions, meaning that when you create a new version, the old version will not be touched. And when I say it's immutable, obviously the piece of code is immutable, but also the configuration of that AWS Lambda function. So earlier when I showed you how I set memory or how I set the first handler of that function, these are configuration variables. These configuration variables are tied to the version of your AWS Lambda function. So if you create a new version, you can change the configuration and not impact your previous version. The CloudWatch metrics which you saw, like the invocation, executions, and errors that happened, are also versions. So these CloudWatch metrics will not overlap, which allows you to identify if a certain version of your Lambda function might run inefficiently or create certain errors. The CloudWatch logs, which log all the output of your function, also contain a version attribute. So you can easily identify where the output came and from which version of your Lambda function this came from. We also allow you to create aliases to label your version release, which is very useful if you want to say, this is my stable release of the Lambda function that has been stable, but maybe for my development, I want to have some tagging for my latest or staging kind of function that I have. In terms of versions, you can, it's basically incremental numbers. If you upload new code, it automatically gets posted into the $latest version, which you see here at the bottom, $latest, which is the latest version of your piece of code. So if you think about actually using such an alias to deploy out your function, you could think about a scenario where you continuously use versioning to have your new piece of code versioned in your AWS Lambda function, but you say, I want to test my application first, the new piece of code of version number 94 here. I'm going to test it, so I'm going to tag it as a testing alias, and my stable is currently still a 93. After I tested this out, I can easily just change my alias of stable to the 94 version of my Lambda function, and this is how I could deploy this 94 version function out into my stable release. Now, if you wonder how that would work, how that would look like, if we use Amazon API Gateway, we have different stages. So here we have, for example, here a development and a prod stage. And that stage can then be tied to the different aliases that we have on our AWS Lambda function. How does that look like? Well, in the stages, we can define stage variables. And these stage variables, we could put any kind of information in. And in this scenario, I put in Lambda version, and I set on my production stage, I want to use the Lambda version, which is tagged as stable. The stage variables are automatically sent to the context object of the Amazon API Gateway mapping templates, which allows me to then set also in that stage how to actually call the Lambda function. And if we create an API Gateway method, we can integrate it with a Lambda function. And the Lambda function, we can indicate the name. In this scenario, would have an ASG_spot_query Lambda function. But we can then also indicate the stage variable here, which I took the context there, stage variable.lambda version, which now means that we will now call this Lambda function that is tagged with the alias as stable, which allows me to pin down my environment with those stage variables. So I could, for example, create a prod, dev, and QA deployment in my API gateway, tag it to a Lambda function, which I call function name here in this scenario, and use the respective alias of stable or latest for my development environment, or maybe a Q&A alias for my Q&A environment. API Gateway allows me to also put custom domains on top of it, so I can easily put this out into something like api.example.com or dev or qa.example.com to have a very nice URL that then ties back to my respective Lambda function in the respective lifecycle of my software development. Now, before I let you off and we go into some Q&A, a few last best practices when using AWS Lambda. First of all, we can choose the amount of memory that our Lambda function has. Remember, it is the memory that is assigned for a single function execution. Now, important to know is that the amount of CPU that is allocated to the AWS Lambda function is proportional to the amount of memory that you assign to that function. So if you create a Lambda function that is CPU bound and probably requires more CPU than memory, increasing your memory makes your code probably execute faster because more CPU is allocated. So in this scenario where we require a little bit more CPU, play around with your memory variable, memory setting, and you might get a better result in the execution time. Don't forget that there's a timeout. Increasing that timeout allows you to run longer functions, but set it reasonably in the sense that you don't want to set an incredibly high timeout for a function that only executes fast. Because in the case of an error, your function will run until the timeout hits, which is unnecessary waste of compute cycles and as such unnecessary waste of the execution time that we would charge you against. Lambda is actually based on containers on the underlying infrastructure. Be aware of the fact that these containers that we use to deploy your Lambda function out have different stages. So there's a cold start, a warm start, and a hot start of that Lambda function. If you run a Lambda function for the first time, there's a certain lead time to the execution of your function. If you subsequently run that same Lambda function, it will be a hot start and it will run immediately and fast. Now, if you say that your start time is crucial and you need that initial first call of a Lambda function to always happen with a very low latency, you can actually keep your Lambda function warm by scheduling a scheduled Lambda function execution of AWS Lambda, for example, every minute, just to keep that container warm. Now, important to note, Lambda function in those containers get deployed very quickly, so this really only makes sense if you need extremely low latency. In the other scenario, just use Lambda in the way I just showed you. Lastly, be aware of safety throttles. In AWS, we always have soft limits, and those soft limits are actually to protect our customer from unnecessary spending through accidental use of a service. The same comes with AWS Lambda. So AWS Lambda has a safety throttle that limits you to 100 concurrent function invocations by default. If you need more function invocations, that is absolutely no problem. You can do so. You can actually raise that safety throttle to any kind of limit of your choice by just logging a request through our support center in your management console. That's it. I want to thank you very much for your attention today. I hope the live demos and some of the things that we talked through helped you with your project, and we're keen to see and hear how you can use AWS Lambda for your next project. Remember, there's a Q&A panel on the side. I'll let you type in your questions and happily answering some of the questions in the remaining time. Thank you. So I see a few questions slowly rolling in. The first question of Dimitri is there no more limit of 5 seconds for a Lambda function? Can I run it as long as I need? Actually, the limitation currently would be 5 minutes, not 5 seconds. So the timeout that I shown earlier can be increased all the way up to 5 minutes. That is currently the maximum amount that your Lambda function can run. If you ever need a longer running Lambda function, you could think about a Lambda function that executes another Lambda function if you require a really long Lambda function in that scenario. Another question coming in here from Patrick, and he asks, so to prevent functions being terminated prematurely, won't it be safer for me to set a very, very long timeout on my AWS Lambda function? Yes, that is true. You can set a longer timeout to avoid having your function being terminated too early. However, I would caution to just set this timeout unreasonably high, because in case of an error, you actually want the timeout to occur and terminate your function. A good practice again here is to actually use your CloudWatch metrics and CloudWatch logs to look at the actual execution time for most function execution, and then use that as a baseline to potentially tweak your timeout values to a reasonable amount that is not too short and yet not too long in case of an error occurs. Question coming in from Alan. Can scripts in Lambda be encrypted? Well, it's your piece of code that you deploy, and you would have the flexibility to use any encryption within that Lambda function itself. As a matter of fact, it is actually a good common best practice if you ever need to have some other credentials in that Lambda functions to call some third-party APIs, for example, to obviously not hard-code credentials into your Lambda functions, but rather have them encrypted and then decrypt them with a certain function call. So yes, you can use your own libraries in AWS Lambda. You can package them up into a Lambda function, and those libraries could, of course, also contain some encryption libraries, and as such encrypt data within your function. Interesting name here from Jen coming in. Why do you have a Chinese name? Well, I am actually a solutions architect who is based out of Hong Kong, and thus I have allocated myself a Chinese name. There are a few overlapping questions here about language support. Some people ask for PHP and C#, etc. We continuously always take feedback from our customers on what are some of the next programming languages that we want to support on AWS Lambda. So always good. We had a poll up earlier, and I saw some good responses coming in. What are some of the programming languages that you might want to see? We continuously roll out new language support and keep supporting new programming languages based on some of our customer feedback. There's another question here. How will CI/CD and automation be different with AWS Lambda? Will that be covered in another webinar or some other implementations that we've seen? So today's webinar was primarily to give you a first overview on how AWS Lambda works, but we're very happy to talk to you in more detail afterwards to see how we can use CI/CD together with AWS Lambda. There's some great frameworks out there that can help you really integrate Lambda well into your current CI/CD pipeline. Maybe even if you use tools like from AWS, such as Code Pipeline or Code Commit, you can integrate that with AWS Lambda. You can also integrate it into other tools like Jenkins, for example, to deploy your functions out. Remember, AWS is Amazon Web Services. Everything is a web service. Everything is an API, so everything can be programmed and scripted in a manner that you can integrate it in your current CI/CD pipeline. But there are some good tools that are available already at this point in time, some of them from AWS, some of them written by some other developers and have been open sourced on how you can integrate AWS Lambda effectively in your CI/CD pipeline. One other question here, since a function will end after the callback is hit, why is there still a need to set the timeout? Well, you're right in the sense that if we hit the callback, the function is terminated at that very moment, and that is the way we want it because we don't want to have unnecessary build execution time here. The reason the timeout is in here is because sometimes we might have an error in our function which would lead to, for example, an infinite loop, or which would lead to a scenario where we might just have forgotten to put in the callback function. If you use Node.js and you have the asynchronous programming model, you sometimes have scenarios where you accidentally, when your piece of code did not reach the stage where you call the callback, and at that very moment, the function should not just run idle forever, and that is why we always need to actually set a timeout configuration parameter, and we should set that timeout reasonably to the function as it executes. All right, that's it. We're slowly running out of time. Again, I want to thank everybody for attending this webinar. Great questions coming in, great interesting feedback in our polls. I hope this was insightful, and we hope to hear from you soon how you use AWS Lambda within your own projects. Thank you, everyone.